When installing a hot tub and a gas pipe is nearby, bonding the gas pipe is essential for safety. Bonding creates an electrically safe environment around a hot tub, minimizing the risk of electric shock. Here's why it's necessary and how to do it. Firstly, understanding bonding and grounding is crucial. Grounding provides a path for fault current to return to the source, tripping a breaker and energizing the circuit. Bonding connects metallic parts together to create an equipotential plane, meaning all conductive surfaces are at approximately the same voltage. This reduces the risk of electric shock if a fault occurs. Secondly, gas pipes are conductive and can become energized if there's an electrical fault nearby. If a gas pipe is not bonded and a fault occurs, a person touching both the gas pipe and another grounded object, like the hot tub's metal frame, could experience a dangerous electric shock. Thirdly, the National Electrical Code, or NEC, mandates bonding for metallic piping systems in areas where electrical equipment is present, including around hot tubs. The specific requirements can be found in Article 680.26 of the NEC, which covers equipotential bonding for swimming pools, spas, and hot tubs. Fourthly, to bond the gas pipe, use a solid copper bonding conductor. The size of the conductor is typically determined by the size of the circuit supplying the hot tub, but it should generally be at least an 8 AWG copper wire. Connect the bonding conductor to the gas pipe using a listed bonding clamp. Ensure the clamp is suitable for direct burial if the pipe is underground. Fifthly, the bonding connection should be made as close as practical to the hot tub, and it should be accessible for inspection and maintenance. Do not make the connection to a painted or coated surface, as this will prevent a good electrical connection. Clean the area where the clamp will be installed to ensure bare metal contact. Sixthly, bond the gas pipe back to the hot tub's bonding grid or the main electrical panel's grounding system. This creates a continuous bonding path that ensures all metallic parts are at the same potential. If the gas pipe is connected to other metallic piping systems, such as water pipes, ensure those are also bonded to maintain the equipotential plane. Seventhly, when running the bonding conductor, follow the NEC guidelines for conductor routing and protection. Avoid sharp bends or kinks in the wire, and protect it from physical damage. If the conductor is buried, use direct burial rated wire and bury it at the appropriate depth. Eighthly, inspect the bonding connections regularly to ensure they are tight and free from corrosion. Over time, connections can loosen or corrode, compromising the effectiveness of the bonding system. Clean and tighten connections as needed, and replace any damaged components. Ninthly, consider the specific requirements of your local electrical code and obtain the necessary permits before starting the installation. A qualified electrician can help ensure the installation meets all applicable codes and regulations. Tenthly, remember that proper bonding is just one aspect of electrical safety around hot tubs. Ground fault circuit interrupters, or GFCIs, are also essential for protecting against electric shock. Ensure the hot tub is connected to a GFCI protected circuit and test the GFCI regularly to ensure it is functioning properly. Furthermore, maintaining the equipotential bonding grid involves a few key steps. 1. Visual inspection. Perform regular visual inspections of all bonding connections to check for signs of corrosion, damage, or loosening. Pay close attention to clamps, conductors, and any exposed metal parts. 2. Tightness testing. Use a wrench or screwdriver to ensure all bonding clamps and connectors are securely tightened. Loose connections can compromise the effectiveness of the bonding system. 3. Resistance measurement. Periodically measure the resistance of the bonding grid to ensure it remains low. A high resistance reading can indicate a problem with the bonding connections. Use a low resistance ohmmeter to measure the resistance between various points on the grid. 4. Corrosion prevention. Apply a corrosion inhibitor to bonding connections to protect them from moisture and environmental factors. This is especially important in damp or corrosive environments. 5. Replacement of damaged components. Replace any bonding conductors, clamps, or connectors that are damaged or corroded. Use only listed and approved components that are suitable for the application. 6. Documentation. Keep a record of all bonding inspections, tests, and maintenance activities. This documentation can be useful for tracking the performance of the bonding system and identifying any potential problems. 7. Professional inspection. Consider having a qualified electrician inspect the bonding grid periodically to ensure it meets all applicable codes and standards. They can also provide recommendations for improving the performance and reliability of the bonding system. And 8. Local codes and standards. Always comply with all applicable local codes and standards for equipotential bonding. These codes may have specific requirements for the design, installation, and maintenance of bonding systems. By following these steps, you can help ensure that the equipotential bonding grid remains effective in protecting against electric shock hazards. Additionally, consider that equipotential bonding in swimming pools, spas, and hot tubs is governed by Article 680.26 of the National Electrical Code, or NEC. This section provides detailed requirements for creating an equipotential plane around these bodies of water to minimize the risk of electric shock. An equipotential plane is an area where all metallic parts are bonded together to ensure they have the same electrical potential. This helps to prevent voltage differences that could cause electric shock hazards. The NEC requires that the following metallic parts be bonded together to form the equipotential plane. Firstly, all metallic parts of the pool structure, including the reinforcing metal of the pool shell. Secondly, all metallic components of the recirculating water system, such as pumps, filters, and heaters. Thirdly, all metallic parts of the pool equipment, such as ladders, handrails, and diving boards. Fourthly, all metal conduit and electrical enclosures associated with the pool equipment. Fifthly, all metal piping systems, including gas and water pipes, that are within 5 feet of the pool, spa, or hot tub. And sixthly, any other metallic parts that are likely to become energized and could be contacted by a person in or around the pool, spa, or hot tub. The bonding conductors used to connect these metallic parts must be solid copper and of sufficient size to carry the potential fault current. The NEC specifies the minimum size of the bonding conductors based on the size of the circuits supplying the pool equipment. The bonding connections must be made using listed and approved bonding clamps or connectors. The connections must be accessible for inspection and maintenance. The equipotential plane must extend at least 3 feet horizontally from the inside walls of the pool, spa, or hot tub. The plane can be created using a grid of solid copper conductors buried in the ground or by bonding the metallic parts together with bonding conductors. The NEC also requires that a solid copper bonding conductor be run from the pool equipment to the electrical panel that supplies power to the pool. This conductor provides a path for fault current to return to the source and trip the breaker. Ground fault circuit interrupters, or GFCIs, are also required for all electrical circuits that supply power to pool equipment. GFCIs protect against electric shock by detecting small amounts of leakage current and tripping the circuit. Regular inspections and maintenance are essential to ensure the equipotential plane remains effective in protecting against electric shock hazards. The bonding connection should be inspected regularly for corrosion, damage, and loose connections. The bonding conductors should be checked for damage and proper size. Any damaged or corroded part should be replaced immediately. It is also important to ensure that the equipotential plane is not compromised by any new construction or modifications to the pool area. Any new metallic parts that are installed within the equipotential plane must be bonded to the existing grid. Understanding and complying with the NEC requirements for equipotential bonding is essential for ensuring the safety of swimming pools, spas, and hot tubs. By following these requirements, you can minimize the risk of electric shock hazards and create a safe environment for everyone to enjoy.